Men, and I use the term in a manly way today because we're going to use all of our manly welding and machining skills to produce a high quality repair on this crankcase. So we have in front of us another chapter of Can This Crankcase Be Saved? And you know, upon initial evaluation, this crankcase actually looks pretty good. I'll tell you right now, there are no strip threads anywhere. There are no holes in it. There are no big cracks that penetrate through it. The mating flanges are nice. They're smooth. As a matter of fact, when I split this apart, it may have been the first time it was split. So what, pray tell, you ask, is wrong with this fine-looking crankcase? Pay special attention to this area in the countershaft boss. This is supposed to be attached to the other side. What a tragedy. Let's look at it and see what happened. See what went wrong. A tragedy. A real tragedy. This is as pristine of an Ironhead crankcase as I have seen in a long time. Literally, there is no damage anywhere on this thing other than this unfortunate tragedy. What the hell happened? Well, the owner had it apart. Apparently there was some problem with the transmission. He was trying to reinforce this boss, which people commonly do. So he had a machinist make this ring and press it over the boss where the countershaft needle bearing sits. All went well until he got home and tried to drive in the closed countershaft needle bearing, at which point this cleanly broke off. This is horrible. But anyway, that's what happened. Why did it break off? Well, I don't know. You know, maybe this clearance between the reinforcement and the boss was too tight, and in the course of pressing it on, it cracked. I could tell by looking at it, there's a little bit of a edge here. I have actually made these parts and have done this reinforcement. Sometimes I use steel, sometimes I use aluminum, and I will put a chamfer on this edge so that it can be driven all the way down against the crankcase. This one doesn't have a chamfer on it, and it is sitting a little bit proud of the crankcase, or was sitting a little bit proud of the crankcase. I don't know, created a stress riser, hard to see. Many moons ago, I took an accident investigation class, and we talked about fractures and breaks, and it's awfully hard to tell, but if you look around here, the very edge, like on this half of the circumference of the boss, the grains of metal are a little bit shinier than they are on this side. And one of the things I learned in the accident investigation class was that as a crack develops over time, the surfaces of the metal in the crack before it breaks all the way off will rub against each other and create an area that's a little bit smoother. And to me, without a microscope and doing metallurgical analysis on it, these areas look like they maybe are a tiny bit shinier than the area closer to the center or on the other side, which would indicate that possibly this was cracked around here before it broke off. So of course, if you got a crack and you hit it with a hammer, it's going to break. These parts here look a little more frosty and gray, and a crack that's frosty and gray, that is the point of instantaneous failure. That is, there was no defect until it got hit with the hammer and it broke. So maybe there was a little bit of a prior crack in here, and when you schmecked it with a hammer, it broke off. But anyway, our job here today is to fix this. So I'm going to machine out this entire area here, because you can't really, welding this back in there is not going to be strong. It just isn't. So I'm going to machine out this entire area up to where it's just kissing this edge and just kissing this edge. I'm going to make a piece out of 6061 aluminum that fits just in there with the hole in the middle, of course, for this bearing. I'm going to chamfer the outside edge of the crank on the repair part and the crankcase so that I could get good weld penetration. I'm going to weld it all the way around on the outside. Then I'm going to flip it over and I'm going to weld where it contacts here and where it contacts here. That's going to be the fix. So we're going to go set this up in the milling machine and get started. Okay, before I head out to the machine shop, I'm going to show you this. This is a dummy countershaft, and I made this several years ago just for doing these kinds of repairs, and I've done several different versions of this over the years. In any case, this end of it is a very close precision fit with where the open end needle bearing is pressed into the transmission trap door. We're going to bolt this into the trap door. This end sticks out proud of the crankcase surface, and I'm going to put a test indicator on my mill and use it to center the mill over the end of where the countershaft would be if a countershaft was installed. And then we're going to do our boring. But anyway, this is the fixture I use to set the alignment. Alright, so here's a crankcase clamped up in the mill. This is the boring head I'm going to use. And I've got this little homemade gadget over here for holding the DTI against my dummy countershaft. I could barely read the son of a bitch with the mirror. The mill is a little too small really for what I'm trying to do, but I've used it before and it works. The DTI is at such a goofy angle. Hell, I got to read it with the mirror, so it's really kind of a pain in the balls. Anyway, I got this trued up in there within 1/1000th of an inch. So everything is clamped down. I got 3 toe clamps holding the crankcase in. The table is clamped down. Everything is ready to go here. So I'm going to take my homemade indicator holder out of here, put a boring bar bit in there, and we'll see what happens. We're going to let it rip. And I've got this side of the crankcase hanging out over the edge of the table so I can reach up underneath there and undo the shaft. There's just enough room to pull it out through the clutch bearing hole. And there's just enough room to lose a tool bit through the hole. Stop. Alright, we're going to turn it on and go for it. Cool. Taking a nice even cut all the way around. This hole that I'm boring doesn't have to be any particular size. I'm just taking it out until I hit those 2 bosses inside here. So I got another area to pick up some weld on. Anyway, you got the idea. When I get close to the end here, I'll check back in with you. Alright, I just now kissed this thicker area here and this thicker area in here. So I've got good contact around there to weld it. So the boring bar is ready to come out. This piece is ready to come out, and I'm going to make my repair part here in just a minute or two. Alright, I got here a chunk of 2-inch 6061. The hole that I bored in the crankcase is 2.065. That's good, because what I'm going to do to this piece is face off both sides, face it down to the thickness it needs to be, which I think is 0.800, and I'm going to bore a hole in the middle of this that is the same size plus a thou as my dummy countershaft. That way, when I bolt the dummy countershaft back into the transmission trap door and drop this over it, it will be free to center itself. And just in case my hole that I bored was off center a little bit, the hole that's in this will be centered on the dummy countershaft. You know, the strength isn't derived from the fact that it's a press fit into the aluminum. The strength is derived from the fact that it's welded all the way around. So I actually want this to be a little bit loose to float around in the hole. So let's just face off both sides, drill the hole in the middle, and we'll be ready to move on with this repair. Flip it around, face off the other side, and face it to the thickness I need. Let's see where we're at. I'm at 910. I want to get down to 800 thou. $7.99. We're calling that good. Alright, so we got to bore a hole in this here now. Alright, hole boring time. Boy, that's close. Close, but not quite. I ended up with a hole 0.677. I want to get to 0.685. So I got about, maybe 10 thou to take off of this thing. Piece of cake. That's nice. That'll work. Alright, so we're off to do the weld setup next. This is the repair part. Case is ready. Time to go do the weld setup. Alright, so let's take a minute here and talk about the last function of the dummy shaft. this is the countershaft, and the low gear, countershaft low gear, are removed from this particular trans. And if you measure this thing from the step on the clutch side to the opposite side is 3.940. Okay, so you install this in the bike. This side bottoms against the trapdoor, and this and this gear should have about 7 or 8 thousandths of end play in it. Okay, so when I go to weld this in there, I have to set the depth of this repair part correctly, or I'm either not going to have enough clearance or no clearance, or I'm going to have too much. So I'm going to use the dummy shaft to help me do that. And the way I'm going to do it is this. I have the dummy shaft. I have a junk countershaft low gear that I'm going to leave in place while the welding is going on. I've been digging around in my selection of countershaft low gear spacers, and I found a spacer. And that gets me to 3.930. And this one, what did I say this was? And this one is 3.933 or 34 thereabouts, so damn close, okay? So this one is just a scotch shorter than the shaft that came out of the bike. So I need to account now for the free play on the end of this. So I'm going to get a thrust washer for here and put it on. Alright, so I dug around in my stash of thrust washers and I found kind of a thick one. And it's just slightly proud of the surface of the low gear. And it needs to be, because if you let the low gear hit the side of the crankcase, it's going to just start sawing through the crankcase. So the thrust washer keeps it from hitting. So anyway, what we're going to do is we're going to bolt this into the trapdoor. We're just going to set this on top of there. We're going to throw it all in the oven, heat it up, and when it comes out of the oven, I'm going to weld it up. And that's all there is to it. With a little luck, should be welding in an hour or so. Okay, so here's the final setup prior to welding. The case bolts are all in and tight. The trapdoor bolts are in and tight. The dummy shaft is bolted to the trapdoor in the hole where the countershaft goes. The dummy shaft has a stack up of spacers and a gear on it, so that when I set this on there, it should be just the right height for this particular engine. Here's the repair part. Everything's been chamfered, wiped off with alcohol, and we'll just drop it in there and bake it in the oven. I'll weld it around the edges over here. Should be a piece of cake. Once I get the outside welded, without letting it cool off, I'm going to try to take the cases apart while they're hot, split the cases, flip it over, and weld as much on the inside as I could possibly weld. And that'll do it. Alright, so here's where I left off. I got the welding done. I flipped it over, well, split the cases while it was hot, flipped it over, got weld all in through here and in through here, picked up these two edges. The weldment hit the countershaft low gear, so I put it in the mill and just skimmed this all down and got it flat and got some clearance. So that's the inside. Here's the outside. Outside's all done. The next step is I have to bore this hole to the right size to accept the bearing cup. I did not do that when I made this part on purpose, because when I weld this thing in here, it could distort, it could twist. The bore might not be true. So this is for rough alignment only. I'm going to bolt the cases back together again, put my dummy shaft in, take it out to the mill, recenter it, and then bore this hole to its final size. See you out on the mill. Okay, here's one more note on things before I go back out to the milling machine with this. Okay, here's our trapdoor with the dummy shaft on it. It fits in a hole, obviously, but when that part was welded, and I don't care how rigid you think your fixture is, you know, metal expands and contracts. It has to move. So the dummy shaft no longer lines exactly up with the alignment pins on the trapdoor. So what I'm going to do is this. And this is, like I say, this is planned for to a certain extent. What I'm going to do now is I'm going to just put this on a drill press and open this hole up a tiny bit so that there's clearance all the way around for the dummy shaft. I don't want the misalignment of this welded repair part pushing the shaft one way or the other because it will knock it out of alignment. So the shaft has to have clearance all the way around when I slip it in here. So we're going to drill a hole in this, put the dummy shaft back in, and then take it out to the mill. Okay, I've opened this hole up a little bit. The dummy shaft should now go in without touching the sides, and the alignment dowels are going perfectly. So now I could center my case up on the dummy shaft, bore my hole to match the needle bearing, and we'll be all set. Now I'm going out to the mill. Okay, I'm good this direction. Let's get her zeroed up the other direction. Wow. Zero. Minus maybe a half, not quite a half. 0. And plus about a half. So let's split the difference. Should be very close right there. Boy, I'm calling that good. I'm good. I'm good. That's almost perfect. All right. Let's get the dial indicator out of the way. Let's get the dummy shaft out of the way. Beautiful thing. Okay, up until now, I had always a plan B. At this point, there could be no mistakes. There is no plan B from this point out. This has got to be correct. if you could see it or not, but I write the size I'm shooting for somewhere nearby. The bearing cup is 0.875. I want to have about a 1 to 2 thou interference fit, so my target value is 873, and right now I'm at 0.807. So what have I got? I got about 65 thou to go. So we're just going to take it easy, and we'll get there. Like I say, there's no mistakes at this point. Okay, here's the last look at this. I've done several of these, and I think I have this process down pretty well now. It's a little tedious, it's a little time consuming, but you know, the crankcase with damage to this bearing boss is not unsalvageable. These things can be saved, so don't get discouraged, don't trash your bike. There's ways to fix these. There's other repairs that can be done in this area, but this is how I do these. Got the bearing pressed in there, nice and snug, about a thou and a half interference fit. Here's the inside. Got it machined off. The bearing is relieved just a little bit back from the edge. I've already test fit the counter shaft and checked for end clearance on it, and I got about 4 thou. And I just arbitrarily grabbed the washer. I may adjust that up a little bit more. I like them a little loose rather than a little tight. But anyway, this is it. This thing is going back together again, and I'm calling this project done. Y'all take care. Thanks for watching. Please subscribe, and we'll see you next time. Bye.